Microservices are built with a variety of languages and technologies. grpc can be one of those choices. Today I'm going to have a chat with Saurabh about what we're doing with ASP.NET Core and grpc when building these types of applications. Let's go find him. Hey Saurabh, how are you?
Hey Shane, how's it going?
Good. I was sitting down and I was looking at some docs on grpc with .NET Core and building some apps, and I was a little bit overwhelmed. I was hoping you might be able to help me get through some of that.
Sure.
All right, I've got a spot upstairs. Let's go have a chat.
Cool. Absolutely.
All right. So where does grpc come from, right?
So grpc comes from an age-old project at Google called Stubby. Google had developed it internally because they wanted to do contract-first development for service-to-service communication. But by their own admission, it was too closely tied to their infrastructure. So grpc was the product they put out for everyone else to use. You know, we've seen this with Google before. We've seen how Borg has developed into Kubernetes. So Google's obviously got some experience with running services at scale, and there are good learnings there that I think the rest of us can benefit from. And in similar vein, grpc comes from the Stubby project, but now has been made available for everyone to use, and it's gained momentum in the community. Google tooled it for the languages that they used internally, but now it's actually incubated as part of the Cloud Native Computing Foundation. So that's a part of the Linux Foundation. And as part of that, it's an open governance model like the rest of Linux. And in addition to the original languages that it was tooled in, now the community's added support for multiple languages.
Okay, so we've got C# and Java and Go and
Swift for iOS and Android, a bunch of stuff.
Awesome. So there are other RPC technologies out there. We've used RPC in the past, and Windows and .NET. So what's different about grpc?
So we looked when we were figuring out what is the future of service-to-service communication in .NET. We looked at a bunch of options out there. We looked at Apache Thrift. We looked at Bond, which was made by a couple folks at Microsoft and Bing. And obviously we had WCF that we've used in the past. Beyond technical merits too, there was the momentum of the community behind it. Like, we know modern cloud native developers are polyglots. You probably have Go services and Java services and .NET services. So going behind the project that had the most momentum and was the best tooled and supported made the most sense.
Sure. So when you're talking about services to services communication, so if I go back to maybe some of my maybe early applications, I was probably just kind of maybe 3-tier, where I'm web application, maybe a SQL server, and maybe an API server all involved there. If I'm growing up from that, I might have some multiple services in the back. But now talking cloud native apps, I've got a number of services that are sitting in a cluster, in a Kubernetes cluster. Those services are talking to each other through service discovery. I'm maybe talking out to something like Redis or configuration service to get my settings. Is that the proper place to put something like grpc?
So I would say grpc in itself is unopinionated.
Okay.
You can use it to do applications like you described. You can build stateless services using grpc. If you so choose, you can even build stateful services. An RPC framework is not opinionated on that. Now, for modern application architectures, that sounds like a great idea.
Okay.
This is a great use for grpc. Maybe things like, say, streaming, for example. When you want to stream data between multiple microservices, it was a little clunky with REST and JSON, right? So grpc makes some of those things more natural and easier to do.
So when you say natural, I think that if I'm writing a standard, JSON over HTTP service or a REST service, I probably have to spend a lot of time implementing things like logging and error handling and things like that. Does gRPC help me get past some of those extra work? Is there things that are built in automatically as a part of the project?
So it is unopinionated, but when we talk about gRPC, we talk about the ecosystem of tools and stuff that has developed around it. So one of the things built into the framework is support for deadlines and cancellations. So this is actually a common pattern we see in microservices where you have a causal chain. So service A will call service B, which will maybe call service C and call service D. And you usually have this thing where if something in between fails, it can retry, and that could take down your system. So having deadlines built into the framework is one of the features that gRPC has. And it also has support for tracing built in. So we're actually working on a open trace implementation, and our gRPC implementation will actually have distributed tracing built in the box.
Okay. I want to go back to a key word you said earlier, and you said about contract-based development. Now, if I go back kind of in my roots a little bit, I was really big into WCF development, and that was one of the things that I think I enjoyed, being able to just kind of right-click, add that service reference, and being able to say, I know what my types look like, I know what my contract looks like. You say we're getting kind of behind this service because the community really enjoys it, and there's a lot of kind of momentum behind it. Is this some of the things that gRPC gives us in the tooling that we're kind of putting into the project? Is that the advantages and the things that we're putting into gRPC? Is that type of development in our tooling?
So yes, so some context. gRPC is agnostic of the deserialization format used, but the de facto winner that we see today is protobuf. So in the purpose of answering this question, I'm just going to say gRPC with protobuf. Right?
Okay, fair.
So there is tooling in the protobuf ecosystem to generate types, because it is binary serialized and you need your serializers and deserializers, which we have tooling to generate. And then you also have the gRPC side of it, which is generating service stubs and strongly typed clients that you can use. And so some of that tooling existed for some languages. There are obviously some languages that say aren't strongly typed, like dynamically typed languages,
sure,
where you may not want to do build time generation, you want to do runtime, right? But in the .NET side of things, there is build time generation of your types, and we are adding more features to, say, light up design time build in Visual Studio. So now you have an extremely productive inner loop experience where you go modify your proto file, and now you go back into your service implementation and you do add override, and you have your method right there.
So we're getting some of the great things that we kind of enjoy as .NET developers.
Right.
We're getting some IntelliSense, probably some IntelliCode coming soon, potentially, but it feels natural to us as the kind of the .NET ecosystem inner tooling that we're used to seeing. What are some of the things that we're doing in the project to kind of move the microservice development with .NET Core? We've got .NET Core 3 now out. Are there advantages? Do we have middleware? Is it as easy to add into a project? Can I just do like .add RPC or gRPC to my project? Is it that simple?
So we have some like inner loop features that are shipping. We're shipping new templates that will ship as part of the .NET SDK. We've added support for what we call service references in Visual Studio and via the command line. So if you're used to it as a WCF developer, where you can point at, it was either a WSL endpoint, or in the gRPC case, you can point at a proto file, either locally on disk, so which could be your server project,
right,
or it could be from some URL where you can just point at that, and we have tooling to like automatically refresh and regenerate clients and service stubs. So that's what we have thus far, and we're looking at more investments going forward.
Cool. So do you have a demo? Is there something you can show me, like what does this file new project look like?
Yeah, absolutely.
All right, cool. Let's check that out. So we're going to jump in and see a demo real quick here. I'm curious, you were talking about contracts, and you said the proto file is kind of where we're going to start with this. So
Right.
let's check that out first.
So I have a very simple example here.
Okay.
So this is my proto file. I have the proto version specified here, and I have two things of interest.
All right.
I have the service definition. So I have the greeter service, and right now it implements one RPC method, and you can see that this is the request message type, and this is the response message type. grpc also has streaming RPCs, so I could have potentially had a stream of requests.
Sure.
But let's stick to a simple unary request response here, right?
Fair.
And then along with the service definition, I have my message definitions. So I have a hello request, which just takes a name, and I have a hello reply, which will just say hello my name and send it back. So this is my simple service.
Okay, that's fair.
So what I'm going to do now is I'm going to jump over into my code, and I'm actually going to show you where it's wired up.
Okay.
All right, so like I said, we're working to make it a productive experience. So all the common cross-cutting concerns that we've solved in ASP.NET, so DI logging, configuration, all those all that goodness can still be reused, even though this is a different app model.
All right, so I don't have to work any harder in order to use this. This should feel like
it should feel very natural if you're an ASP.NET developer.
Right.
So the thing of interest to show here is this is my startup.cs,
okay.
And in my configure method, this is where I set up endpoint routing. I have this map grpc call.
Oh, great.
And I actually map to a concrete implementation of this service.
So this would be very similar if I was setting up just like an API endpoint if I was using Web API. Okay, cool.
So if you were doing SignalR, it works the same way, right? It's endpoints map SignalR hub.
Oh, okay,
it
great.
looks very similar.
Yeah.
So I think the next thing we should do is look at actually the implementation of this service, right?
Yeah. And this is the server side, because my understanding is we need a server and a client for grpc, right?
That is correct.
Okay.
So this should look very similar if you've done ASP.NET. This is a scoped service created when your request comes in. We have constructor injection through which you can resolve a logger, things like that. And then what you have to do is you have to override the default implementation of this method, right?
Sure.
So here, all I do for say hello is I get a hello request. That's my request message, and I just crack it open and I reply with the message that says hello and the request that I received.
So this does feel very natural. I think that sometimes when we see a new technology or like the new player on the block, we think, oh, I've got to learn something completely new. And I think that just with what I've seen here, I don't feel like there's a huge barrier to entry for me. I can just jump in and do this. And it's just really just like implementing a whole nother interface, and I can get moving on it, right?
Yeah, and just if I were to be pedantic, you said interface, but the way this is actually implemented under the covers is the generated service stub is abstract class that we need to implement.
Sure.
So we can actually jump into the generated code. So if I go here, so I've already built this project. If you're in Visual Studio, you get design time build. So if I go to my obj folder, you can see here I have two files of interest. I have the greet.cs, which is all the generated message types. So let's look at that one first, right? And in my generated message types, you can see I have my hello request message, and I have my hello reply message, should be somewhere here. If I keep going. There you go. And here's my hello reply message, right?
So this is the contract then that it gets generated, right?
Right. So these are proper C# types that you can use.
But this is similar to, if again going back to my roots of WCF, if I was generating the client from the WSDLs, this is what I'd kind of be used to seeing. So it would feel a little natural.
The distinction I want to make is right now I've just shown you the message types, which protobuf can be used independent of grpc.
Okay.
You could use protobuf in your web APIs as well,
okay, great.
as an example.
Yeah.
And the part that you were speaking about, that's in this file. This is the greet grpc file. This has the base class for my where'd that go? There you go. So this is my grpc, this is my say hello method,
Okay.
and you can see it's a virtual method, so I can actually override it in my implementation.
Nice. So what does this look like running? I'm assuming that we've got to fire up a client, we've got to fire up a server to do all the work.
Let's take a quick look at what this client code looks like as well.
Okay.
Right, so on the client side, let me go back here. So we were looking at the server project. I have the client project here as well. So it's very simple. So I have a grpc channel. So this is a static helper method that helps me generate a grpc channel. And this is the address that my server is listening on. And once I have a channel, which I can use that to new up a client, and all your methods that you expect just hang off the client itself.
Oh, okay.
So I'm able to just call client.helloasync, and the way this works is it uses the same similar code generation. So if I look in my ops folder, there's a generated client in here as well. So this is on the client side.
Great.
Should be here, yeah.
Perfect.
So I can jump over and show you this actually running. So I have a tmux session here, I have my server on the left, and I'm going to run my client on the right.
Great.
And actually run it. It looks very similar to ASP.NET because it does use ASP.NET. So I have my server up and running. It's listing on port 5050 in this case, and I had showed you in the client configuration code. So now if I go ahead and run this, it's going to run, and you can see the logs for this request.
Sure.
And that's my simple unity RPC call. Now obviously I can expand it. I can do both unidirectional client streaming or server streaming, or like full duplex bidirectional streaming.
Sure. So this seems really simple. Like you showed, it's very natural to any ASP.NET developer. It's got our logging, it's got our dependency injection, and it's not a scary thing to jump into, right? So perfect.
And I just want to add to that, we've actually tried to keep it natural both for ASP.NET developers, and if you were an existing gRPC developer, especially if you use the existing .NET implementation of gRPC, we've managed to keep API compatibility so you can migrate your services, and then you get the extra goodness of ASP.NET.
Cool. All right, so what's next? Kind of where are we now? You mentioned we've got templates, Visual Studio, and also in the CLI, the .NET CLI. Kind of where are we going? Kind of what's the goal of us with the project?
So, like as with the rest of ASP.NET Core, one of our goals has always been performance. So we're looking at performance all around. That includes improving the server performance. That would be the HTTP2 performance in Kestrel,
Sure.
the HTTP2 performance in HTTP client, as well as the serializer, deserializer performance work. If you're familiar with some of the JSON work that we've done in the 3.0 release, where we've tried to make non-allocating deserializers, we're trying to do something similar in the protobuf space as well, or at least reduce the impact of allocations and then ergo the impact on throughput caused by that. In addition to that, we're looking at new transports. Not all RPC communication is off-box. You might want to call another service on the same machine. So we're looking at Unix domain sockets, Windows named pipes. We're also looking at future transports. If you're familiar with HTTP3, it actually uses QUIC and not TCP as the underlying transport. So we're looking at investments in future transports. And in addition to all the perf work and standards compliance, like future looking stuff, we're always looking to improve developer productivity. So inner loop improvements to code generation, and other things that we can do to make your inner loop experience more productive.
Cool. Are there any rough edges when it comes to developer experience or publishing this to my production servers? Is there anything that I need to be kind of aware that, okay, now I've got it running on my dev box or my local machine? Is there some things that I just need to kind of be aware of? Are there ports? Are there things like that we need to worry about?
So one of the challenges that we've seen a couple of folks run into with gRPC is that it uses HTTP2 today.
Right.
And a lot of servers have not implemented a full fidelity HTTP2 implementation.
Okay.
And gRPC really stretches it. It relies on trailers. It relies on, sending resets with specific error codes. So if you are running on a PaaS, you're running behind a load balancer. If you're doing any sort of HTTP ingress or egress, you might want to make sure that those HTTP servers or clients actually support the entire requirements of gRPC.
Okay, so reach out to whoever your host is or your IT team and make sure that we've got that kind of all the way through as a requirement. Awesome. Any final words on the actual project and kind of what you're hopeful for and what you're doing going forward?
So one of the things I don't think we got a chance to focus on much is this is a project that we're doing, that we're donating our code and our time to the Cloud Native Computing Foundation, which is a part of the Linux Foundation. So what we're trying to do is we're trying to grow the community, and we're seeing great success working with Google, working with other contributors from the CNCF, and we're really buoyed by it. And we want to take these learnings and use it across all other cloud native efforts that we have. We really want to grow the ecosystem of stuff, because working with other people, we've been able to accomplish a lot more than we would have done by ourselves.
Sure, and that's the point of us getting not only .NET in the open source, but it's also us contributing to other projects in this space. So we actually build greater things, by more hands being into it, right?
And we learn from others' mistakes.
Yeah, and we learn from our own. Awesome. I appreciate you taking the time, learning more about gRPC. I know that I'm less frightened by jumping into something new like this, and I hope our community is doing the same. So I look forward to seeing where we're going with the project. So that was another episode of the Cloud Native Show on building apps with gRPC. Be sure to tune in next time on aka.ms/Cloud Native Show. Thank you. Thanks for watching the Cloud Native Show. Be sure to subscribe, watch for future episodes, and especially our streaming shows on Twitch, where we build apps based on the conversations had right here. We'll see you next time.